Hello everybody! I'm in the Mount Sinai Center in New York visiting the team working on our phospholamban mutation. I'm here with Irene, with Kevin and with Irene, Kevin and Francesca. The best movies are when something goes wrong, so this is the first mistake. Okay, Francesca, you're working on it very hard also. Can you tell us a bit about what you do?
Hi, everybody. So I work mostly with an animal model that was made here at Mount Sinai as a transgenic mouse model of phospholamban. We did a humanized animal model, as mouse model, with a mutated phospholamban, and we found interesting data, which hopefully we're gonna publish soon, on finding similar phenotype to what has been found in humans. And importantly, we used the gene editing in order to correct the mutation, and we were able to rescue the phenotype, which was mostly an arrhythmic phenotype. So in the treated mice, we were able to rescue the arrhythmogenic phenotype. And this is a really promising therapy, which can be eventually translated into humans soon, hopefully. Thank
Yeah,
you.
we'll follow you on that. And next time when I'm back here, I hope you have further results. Okay, Kevin, can you tell us a bit about what you do?
Sure. Hi, my name is Kevin Costa. I direct a laboratory here in cardiovascular cell and tissue engineering, and my background and training is in biomedical engineering. So part of what we've done is develop these engineered tissues, these human heart tissues, in the laboratory as a strategy to help translate some of the work like Francesca is doing from animal models into human patients. We feel like it's important to sort of bridge that gap where you have to take a leap of faith typically in going from an animal to testing in a human. We now have technologies that allow us to create human beating heart tissues and test compounds, test therapeutic strategies, and understand mechanisms of disease within these tissues. And so I think, yeah, one of the strengths I think of the program here is this multidisciplinary approach to the work that we do. We're inspired by every time Peter comes and gives us some pressure to make sure the project continues to move forward and stay focused on the patients that are that we're hoping to benefit at the other end. People like Francesca with her background in biology and developing these animal models, my tissue engineering background, and I think I'll pass it on then to Irene Turnbull, who was trained as a physician and is taking on a major role in creating these engineered tissues and testing them for the phospholamban phenotype.
Yes, thank you. Hello, everybody. So I'm Irene, and so I've worked with Francesca on this project, and what we did was once she had cells that came either from a patient with a mutation and also from a healthy subject, I fabricated human engineered cardiac tissues with these cells, and what we were able to show was that the tissue that was fabricated with cells from a patient with a phospholamban mutation actually was weaker, so sort of demonstrating a failing phenotype, a decrease in cardiac function. So this served as a proof of concept that we can use this human engineered cardiac tissue by measuring the contractile force of these tissues as a system to replicate what happens in patients. And even further than that, then Francesca, what she did, she took the cells with the mutation and she did a correction. And after she did the correction, she gave me the cells and I made the engineered tissue. We tested them again, and now the tissue was stronger, so it recovered even better than the control. So that's the line of work that I do. Francesca makes the beautiful cardiomyocytes from different types, and I make the engineered tissues. And using all the techniques that Dr. Costa has developed, we can test them and generate different results and also more questions to be answered. Thank you.
Well, thank you all three of you and wishing you all the luck. Nou, changing back to de Nederlandse taal, om jullie het ook in het Nederlands even een klein beetje mee te geven. We hebben vorig jaar een project gedaan door voor een heel aantal families bloed af te nemen, waarvan we een soort stamcellen kunnen maken. Daarvan kunnen we dan een soort hartweefsel maken. Dat wordt hier gedaan. Kevin en Irene werken daar heel hard aan. En Francesca werkt vooral aan het maken van die lijnen om die stamcellen te kunnen maken. Maar Francesca werkt ook aan de muizen en ze hebben net een proef gedaan hier ook met een gentherapie bij muizen. En daar zijn hele veelbelovende resultaten uit vandaan gekomen. Nou, zijn jullie weer eventjes bij met wat er allemaal in New York gebeurt. En tot het volgende filmpje. Helemaal goed. Tot ziens.